the industrial data starts at the plant floor. And so, again, we can obviously spend a lot of time discussing the different formats, but you have your analog and digital data that is collected by your machine. Then it is usually sent to your PLCs for control systems purposes, right? And so this is where we can have, deeper conversations as to what is control system data, what is data that will be used to make decisions, but ultimately it gets used primarily for controlling the equipment.
Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to the latest episode of the Trend Detection Podcast. I'm really pleased to be joined by Vlad Romanov, and we're going to be talking today about industrial data from sensors to strategy. So it's a really interesting topic. I mean, we've covered sensors in detail, we've covered strategy in detail, but maybe not in between as much. So I'm really excited for this session today. I'm going to make a confession to start with, because we have already had this conversation, and Vlad has very kindly agreed to re-record. We had a bit of a technical issue where the recording corrupted or didn't come through properly. So unfortunately, our fantastic conversation we had before is lost forever. But I'm sure we'll do a better job this time either way, Vlad. So welcome back, and thank you for your patience.
No, absolutely. Thank you. Thank you so much for having me. I think it's an important conversation to have in our industry. So happy to be back, and let's make it happen.
Fantastic. So, I mean, let's right at the start. It'd be great if we could find out a little bit more about you, Vlad, your role, what kind of things you're working on at the minute, and all of that good stuff.
Sure. So formal education in electrical engineering as well as an MBA from Canadian universities. I have spent over a decade of my career in manufacturing and industrial automation settings. I worked for very large end users to start my career. Procter & Gamble, Kraft Heinz, Post Holdings. Again, very plant floor heavy. So, setting up machines, programming PLCs, HMIs, SCADA platforms, before making a transition to a systems integrator, where I learned a lot more about industrial data, what it takes to create enterprise networks, what it takes to, extract, basically store and synthesize information for various stakeholders in manufacturing. And we'll get into some of those details a little bit later. I've been in both, like I said, very large environments, but also in startups. I spent a couple of years building a DevOps solution. So I've also gained an appreciation, not only again, from my earlier years, spending a lot more time on the OT side, but also learning about IT in a lot more depth than I would say a lot of the manufacturing teams have the capability, at least in my experience. And so currently I work on a variety of different projects. I still do a lot of very traditional integration and sort of modernization type of initiatives, pretty much starting with a plant assessment and then going through projects of upgrading, whether that's PLC systems, servers, networks, tying in all of that data back into a on-prem database or a cloud database, and then obviously funneling that into a SCADA and MES type of a solution that allows basically manufacturing personnel to drive better decisions. I also have a few other projects, on the consulting side and private equity type of due diligence work, again, based on my financial and business knowledge gained primarily from the MBA. Again, happy to discuss any and all of those angles with you today.
Fantastic. And thank you for such a comprehensive introduction. I think we might need about 3 podcasts to cover all of that, but no, we'll see how we go, but in a good way. I mean, so you'll be definitely invited back again. But I mean, let's start at the basics. And this might seem quite basic to people listening, maybe, because I'm going to sort of ask you to start by defining industrial data, which everyone may have their own view or opinion on, but from obviously your perspective, but also how that sort of changed over the past sort of 10 years or so.
Yeah, so starting with, I guess, the plant floor, right? Again, those that operate machines will usually notice the sensors that are present for detecting various, I would say, materials on the conveyor belts inside the machines during the transformation. So the industrial data starts at the plant floor. And so again, we can obviously spend a lot of time discussing the different formats, but you have your analog and digital data that is collected by your machine. Then it is usually sent to your PLCs for control systems purposes, right? And so this is where we can have like, I guess, like deeper conversations as to what is control system data, what is data that will be used to make decisions, but ultimately it gets used primarily for controlling the equipment. Secondarily, it is used to be funneled, as I mentioned, to make decisions, and that can be your edge IPC, your edge solution that will synthesize or I guess collect a portion of that control system data, store it for historical purposes, draw certain, I would say, maybe definitions based on that information, add timestamps, right? So usually your control systems are going to be cyclical, whereas you want to make decisions based on a time period. So you need to create more information than what the control systems generally provide. And so if I want to take a step back, maybe and define what is industrial data, I would say that it is the umbrella term used for any and all information that will ultimately touch or have an impact on the plant floor. But me as Vlad, I would take that a step further and say that there is maybe control system data that is used to run the actual equipment, and there is data that is used to make decisions. And we can get into the distinctions of both, but ultimately they will be, from a technical and a business perspective, somewhat different. To your question on how did things change, well, I would say that there was always an appetite for data. I think that, SCADA systems have existed for many years and decades. And in a very broad sense, every manufacturer has always captured the information on how productive they are, right? And so in the early years, that would be maybe using a clipboard or a whiteboard. So a lot of times you go to a plant, they would have sort of a sensor at the end of the line. They would read how many cases are coming through in, let's say, an hour or a shift. They would write that down on a whiteboard. I think that the major change, of course, and I would say since COVID, because everyone wanted to work more remotely or couldn't be at the facilities, everyone is trying to get as digital as possible, right? So now we see a lot more implementations of SCADA systems that are properly, I would say, digitalized, a lot of MES types of application, manufacturing execution systems that allow you to, again, take that a step further and provide insights. So industrial data, like I said, was always there in a general sense. It's just been a lot more digitized, I would say, in the last probably 6 or so years at this point.
And I guess maybe let's start there. Why has the digitizing started in the last 6 years? Because I mean that seems quite recent to me actually. But is there a reason why then's the right time? Maybe it's a difficult one to answer, but
Yeah, so look, let me, I guess, take a step back, right? So I think in our industry, there's quite a wide gap between sort of the cutting edge and bleeding edge, if you will, companies versus, I would say, the medium to small manufacturers, right? So it's not to say that there was never digital solutions. I guess from what I've witnessed during the time of COVID, at least, so I've been to, as a result of COVID, to many facilities during those 2 years, right? And of course, we can talk about sort of the career shifts that people have made. We can talk about the fact that, it was very difficult to get inside of a plant without proper clearance, proper checks. Again, they were maybe looser or more restrictive depending on the region in the world that you were in. But ultimately, um, manufacturing needed to keep going, right? You had no choice but to manufacture. And I do a lot of food and beverage and CPG type of facilities. So as you can imagine, there was a lot of pressure to continue working while all of these shutdowns are happening. So of course, personnel needed to be able to evaluate how well are we producing, where are the deficiencies, where do we invest our capital, right? So there was a lot of pressure to make those decisions, and it was more difficult to access data that was manually created. So therefore, I believe we saw this sort of roll up from medium, at least manufacturers that didn't have or didn't have a big incentive to have a lot of those digital solutions to roll them out. Does that make sense?
No, it does. It does. I think it leads quite nicely on to sort of my next question, and actually what you were talking about before. So you talked about different the flow of data from the shop floor, from sensor, all the way up to sort of strategic or enterprise level decision making. But could you describe that in a bit more detail? Because it seems quite, someone like me, maybe a little bit on the outside, a little disconnected, right? You've got data here, which at the end of the day should inform strategic decisions at board level, for example. So
Sure.
how do you
So
connect
I,
that?
I like to use, I guess, like props maybe a little bit to answer that question, right? And you
Yeah,
see behind me, there's a couple of PLCs. There's one from Siemens, Allen Bradley. There's an IPC from Siemens. There's basically a non-industrial computer, right? And so to paint you a clear picture of an architecture, and let's start maybe with a simple example. So when you have a standalone machine, you will typically have your sensors tied to a PLC, and then that PLC talks to an HMI, right? So that data, in a sense, is contained without that piece of equipment, right? And of course, when I say a machine, that could be as simple as a palletizing machine, a case packing machine, but it could be an entire process, right? So for some facilities, you will have a larger sort of quote unquote machine or area that is going to be controlled by that standalone type of system. And so in that case, your data is basically going from your sensors that are your outputs and inputs on the PLC side, and it's controlling your motors, it's controlling your different valves, it's actuators. There's going to be specialty modules, right? So your data is basically contained within that system. As you start basically growing those operations, you're looking to make decisions on a slightly higher scale. And as I mentioned before, you're looking to control more pieces of equipment, but you're also looking to understand more pieces of equipment, right? So this is where, and again, there's a lot of debates in our industry between, let's say, SCADA function versus MES functions, but basically picture a production line where you have a sequential step of processes where you want to see what is the filler doing, what is the case packer doing, what is the palletizer doing, and you're trying to understand at the end of the day, you're trying to understand how can we better the throughput of the finished product, right? Because if we take a step back, what is paying the salaries and the how would I say it, making the incentives for any of these types of projects? It's obviously product created by the manufacturer, right? And so when we talk about data, we're trying to understand, well, where is first and foremost the bottleneck on our line? Why is that a bottleneck? Is it because it's going down? Is it because it's breaking? Is it because the operator is not loading the raw materials fast enough? So data allows you to start understanding that from an enterprise level, right? And so as we take another layer up, right, when we again talk about plant maturity, now you're trying to understand not only a single line, you're trying to understand the entire facility. So depending on whom you visit, they may have an area that runs a specific SKU that might be a lot more critical for that specific business unit, right? And so now you're trying to understand, where do we invest? Do we invest in this specific line that runs SKU XYZ, or do we invest in a secondary line that runs perhaps some different products? And so then you're starting to again funnel that data from the plant floor into these, I would say, more cloud native, but ultimately more consolidated types of solutions, where you're not looking at the sensor on the machine. You're now looking at, how is my line performing? How is this side doing, right? So you're starting to have a much more higher level view of your entire operation on a multi-site basis.
And I guess another sort of aspect to this, with all those different sort of data sources, what we're talking about is data integration between IT and OT systems, which is of course always sort of top of mind during sort of these large, large and small projects. But how can organisations how should they approach that, and what are some of the common pitfalls around integrating those different data sources?
That is the very difficult question, right? For many years, I've had conversations on both sides, and I simply believe that there is a difference in it's a generalization, right? There's generally a difference in KPIs associated for both teams, and you will generally see, again, engineers on the IT side have a different perspective on what's important versus the OT side. And there's not necessarily anything wrong with that. I just think that to, there's generally a need to orchestrate so that they don't clash during the implementation, right? And what I mean by that is the OT side usually prioritizes, like I've mentioned a little bit earlier, product out the door. So if you've ever been in any commissioning project, you will very quickly find out that there's a very strict timeline. We only have access to, let's say, the line being down for a very specific number of hours or days to implement whatever change. And you have a lot of pressure to make sure that product gets made. So, of course, you're going to not necessarily cut corners, but you're going to do whatever is necessary to make sure that equipment runs. On the IT side, the priorities are different for, again, different reasons, but usually they are trained to mitigate risk from external cyber attacks or ransomware. They're used to manage access to those systems. They want to make sure that everything is secure on the data side. They want to audit, the protocols that allow you to pass different data. And so, of course, the two priorities need to align in a project that's going to touch both sides. So usually, again, going back to the point of data, if it's a standalone machine that gets deployed on the plant floor and it doesn't need to communicate anything outside of that environment, usually OT will be more than capable of handling that project. But as soon as it touches your SCADA and MES layers, and again, there's going to be, of course, a lot of auxiliary things. It could be on the quality side, it could be on the laboratory testing side, right? So there's going to be a lot of sort of like gray areas as well. IT needs to get involved, right? And so usually they will provision hardware, so your servers, they will provision your virtual machines upon which a lot of the software is going to run. And so they primarily, from their standpoint, they don't need to understand what the data delivers to the plant floor, but they need to understand how it's going to be secure, who is going to have access. A lot of times, who is going to, from the outside, be allowed to remote in, and make changes? How are they going to make those changes? How are we going to I've been through these conversations many times, but who's going to upgrade your Microsoft, directory service? Who's going to upgrade the server instances? So there's going to be a lot of questions that, again, concern IT, whereas, again, OT is usually not going to be trained on the server architecture of a facility.
And I guess in amongst all that, because of course there's a lot of technical considerations, but what I sort of noted down, I was writing down there, is more around, there's a lot of cultural differences, not maybe differences, but approaches, I'm going to say, because neither approach is wrong, right? But it's just different mindsets, different goals. And I guess it's trying to align some of those goals together, I guess.
I think for me, it's, to be honest with you, over communicate your objectives, right? So like I said, I believe that both groups are trained in, to some extent, like different disciplines. Ultimately, they do have an aligned objective for the business, right? They are trying to make sure that the business will continue to function as expected. I think it's just maybe a misunderstanding of what the other is trying to do that scares the other group, right? So if I'm putting on my OT boots and I'm just trying to funnel data, obviously I'm trying to understand how the machines are running, and I'm trying to, basically have a good overview of the plant floor. But that scares the IT team if I don't explicitly tell them what I'm looking to have access to, how it's going to be stored, right? And having those conversations is going to help solidify some of that understanding. Similarly, if I'm on the again, on the IT side, I need to be very clear. What does it mean to have access, have permissions? How do I access different layers of the servers? Because again, people on the OT side usually are not trained there, and they get worried when, it becomes way too troublesome to support equipment that, was deployed in a facility 30 years ago and requires a parallel port to connect to, and IT is revoking that access, right? So I think it's being very explicit on both sides in those conversations that can and sometimes does solve some of the conflicts.
And do you think that relationship is maybe stronger compared to previous years, or I know it's a general question because it differs across organisations, industries, etc. But do you feel that's stronger for those reasons you mentioned there?
To be honest with you, I wish I could say yes. But what I see is, I believe that the technical complexity is increasing on both sides, right? And we can talk as to why that is, maybe in a separate question. But I believe that there's a technical complexity increase in both OT as well as IT environments, and at least from what I have seen, the projects are having a harder time now because of that sort of like mesh well between the two teams.
Exactly, and maybe this is a good time to sort of look at tangible examples as well. So you've obviously worked with and you mentioned you've worked at, but also with sort of huge manufacturers. I'm not sure you can mention names, but are there sort of examples where data's really transformed the way they work from the plant floor upwards, right?
Yeah, so I guess let me start maybe with sort of a few examples earlier in my career, right? So I started out of university to work for Procter and Gamble, where I learned pretty much a lot of the foundational knowledge, A to Z, when it comes to data, operations, industrial automation, and I can tell you, bar none, that they have some of the best, I would say, engineering. At least within the facilities that I was at, where data is leveraged to a great extent. And I'll give you a couple of tangible examples. So, we utilized a software, and this is public information, called Prophecy by General Electric for our MES, Manufacturing Execution Systems layer. And basically, what that meant is we would get very granular information on the types of faults that would happen on the lines, the duration of those faults. We would obviously get OEE, but typically, again, on the engineering, would be concerned about mean time to repair, mean time to failure. And so we would have very specific meetings with the operational teams that would conduct them on a shift basis, but we would check in with them usually on a weekly basis, on a monthly basis, to figure out how do we allocate capital and resources to eliminate some of those failures, right? And so P&G was very strong on the cultural side as well as the technical sides to drive changes through the data that was available on the plant floor. Now, again, just to add to that maybe point, a lot of that infrastructure was already in place when I came in. So in hindsight, right, and now having seen, I would say, like hundreds of other different facilities, I can tell you that it is very difficult to create that environment to be able to leverage that data. And I will say that in more recent years, again, to talk about some of the initiatives in plants that are not, I would say, or do not have a system of that caliber, a lot of time is spent, at least by me, is going to the plant floor, understanding the assets, right? So doing a full audit of what do we currently have there, understanding first and foremost, can we extract data in its current state? And the answer is, again, usually from a consulting standpoint, is it depends, right? And of course, it depends on how old is the control system, what is available at the plant layer, how can we actually communicate via those protocols, and that's a whole other, technical maybe conversation. But you start piece by piece extracting the information from, like I mentioned, a filling machine, your case backer, your capper, your labeler, your process side. You're trying to understand the batch. Then you're starting to get into, I would say, foundational or fundamental metrics like OEE, just to try and understand the baseline. And then you start to drill in a little bit deeper. What kind of fault codes are you getting? What's stopping or what's preventing the machine from running? And like I said, it goes facility by facility. In certain cases, the problem lies in the equipment. In certain cases, it lies in the way it is being operated, right? So like I mentioned, if the operator doesn't load, for example, the cases for the case backer to, encase the product and ship them to the palletizer, well, you need to create better, I would say, systems for your people to make sure that happens, right? So there's going to be a lot of different examples how it is leveraged to get tangible results.
Yeah, and maybe you could sort of summarize some of that a little bit in terms of some of the key, is there sort of common themes which have led to success, that across those different examples, if that makes sense, just to. if you out and dive into them a little bit.
Yeah, so what leads to success? I would say, like, number one, have a good mindset when it comes to data. Like I said, I do a lot of plant assessments, and I almost always can feel when the team is on one side is excited to see more insights and information so that they can make changes, right? So basically, the team is very CI focused, so continuous improvement focused, but lacks the information from the plant floor to make certain decisions, right? They don't know how well the performance or how poorly the performance was. On the other side, right, for teams that are unsuccessful, a lot of data gets questioned. Whether you come from the plant floor or the executive side, the reality is a lot of that work is fairly complex. So a lot of teams simply give up too quickly before they get to a state where the data is reliable. And like I said, I spent many months, even years, going to plant floors, sitting next to the machines, understanding what kind of information we can extract so that it actually is meaningful for that specific team. So I think that, having the approach of we're going to take this time to learn what we can, to again have maybe this iterative feedback loop where, in this cycle we've done our best, but maybe we have some inconsistencies versus the data that we would like to see. Let's iterate again, and slowly but surely you will see those gains. So I would say that is by far the main success factor, is sort of the attitude the team has towards being data driven. Number two, and of course, there's going to be a lot of fairly old facilities. So when you start your audit or assessment of the facility, it is very easy to get discouraged by the price tag when the facility has been neglected for decades. And again, to give you a tangible example, I have been to a couple of facilities as early as last year where they have the entire architecture on it's PLC 5s. So in North America, a lot of Rockwell equipment, but it's PLC 5s on Data Highway Plus protocols using RS-232 SCADA systems, and running servers and PCs basically for some of those applications as far back as Windows NT. And so, of course, when the manufacturer is presented with a strategic plan of action for that specific facility versus a facility that is a little bit more modern, there's quite a few steps that you need to take before you can extract and use any of that information. Right. And again, we can get into the complexities of getting data out of PLCs older than you and I. It is obviously possible, but it's very expensive. So usually you need to go through a number of steps to modernize not only the control system, but also the architecture, the networks, your server architecture, before you even get to collect any information in any meaningful way. And so I think that is sort of also the other benchmark of success or failure that I have seen in facilities, right? They simply see this very large, I would say, technical debt type of a bill, and they get discouraged from going down the data path.
Yeah, that makes sense. I guess it can be quite overwhelming, and I guess a lot of it has to be done sort of step by step as well, right? It's not, to stop it from being necessarily that overwhelming. You could put the foundations in place, build on top of that, and then my next question was actually going to be towards where AI and machine learning then sits amongst everything we've talked about so far. Yeah.
So look, I guess to answer your earlier comment and the previous train of thought, right, is a lot of that work needs to be done in sequence. Exactly as you said it, you cannot skip some of those steps. And more so, everyone would like for that work to be done over, again, plants have shutdown periods, right? So everyone would like for that work to be done within a weekend. Come in, retrofit all the PLCs and servers, everything is good to go. The reality is that you still need that physical labor component where you're actually obviously managing a team of electricians that will touch a lot of those systems. And then you start getting into, well, this system talks to this system via this specific server. So now you're starting to touch so many different areas that it becomes almost impossible to piecemeal it together over many different initiatives. So where does AI and machine learning come into all of this? Well, I do have a few thoughts. So I think it is fairly good for knowledgeable engineers that do have access, or I would say that have spent quite a few years on the plant floor, where you can query of a specific problem and you can generally get a good answer. And this is maybe we also want to separate sort of machine learning and LLMs, which is, I guess, what a lot of people are discussing. I think that there's still a challenge in getting very accurate answers from the current state of LLMs in the industrial automation space, right? And what I mean by that is, if we look at the software industry, if we look at the software as a service development space, there's been just countless, not only white papers, but also very solid websites with like Stack Overflow, I guess, with tutorials on how to program, how to utilize data, how to create something in a variety of different languages. And I would say that JavaScript, Python, anything that's front end, HTML, CSS is extremely well documented. In our space, that is manufacturing, if we talk about using AI and machine learning for development of some of these systems, it becomes quite tricky because, number one, there's very little documentation. There is, number two, companies are generally very secretive with what they develop. It becomes, to an extent, their IP. So there's just not enough information being shared for AI to be useful on that side. But where AI, like I said, where AI does come in is, if you're an experienced engineer and you're looking to query or understand maybe the state of certain hardware or processes, I think it's a really good tool. I've also I've done quite a few of initiatives on the cybersecurity side. And again, maybe to take a step back. So when you do an assessment, there's going to be a lot of pressure to understand sort of the networks and the server architecture. And that's a result of some of the regulations that we've seen in the European Union that are coming to North America. So a lot of plants are also looking to modernize their, like I said, network infrastructure. So AI is quite good at, hey, we have this inventory list of different assets. We know that that is the current state of our infrastructure networks. We can now plug that into AI and allow it to basically find all the loose ends and prioritize some of those tasks and equipment. All right. So to give you a tangible example, if you have a Cisco switch of a model that's been obsolete by 10 years, usually Cisco will have some kind of a PDF or migration guide that will tell you, well, to move from that switch to, a switch on the Meraki platform, as an example, here are the steps you need to take. Well, for a human or for an engineer, you will have to manually do that research in most cases, whereas AI can scan through a lot of those documents and recommend changes for the manufacturer to follow, right? So you're going to shorten a lot of your sort of project times by utilizing LLMs in their current state to do a lot of that legwork and research in the industrial automation space. There's a few other use cases, but happy to expand.
No, exactly. I think, and do you see? I mean, the people, the organisations you speak to. I mean, what's their view on AI? First of all, and again, I know generalised question, different views, but are most sort of embracing it, or are some cautious about it, or what's the general sort of feeling, Vlad, from your perspective?
So look, I guess we need to maybe split that a little bit. So almost every large organization has rolled out a flavor of a Copilot, right? A lot of them are in Microsoft, so it's going to be a Copilot license for pretty much everybody at the organization. How it is used, of course, is the big question, and what kind of tools they use for specifically manufacturing is the big question. I think there's no doubt in most people's minds that AI can write, let's say, a better email, can pick up tonality within an email, can help you, maybe do sales outreach, is probably better in certain cases in marketing, right? And again, when I say it's better, it's usually better than someone with very little experience, right? But probably struggles to compete with someone who has a lot of experience. It just becomes a tool. In the industrial automation sense, again, I've seen engineers get access, like I've said, to either Copilot, or it could be Gemini, or it could be ChatGPT from their organization. And of course, they will query using the information that they have from the plant floor. Again, to give you a very basic example, hey, I have this specific fault code on this machine. What can I do to remediate that problem? My experience has been, like I said, a little bit mixed. I would say that the senior engineers, when they get a false positive, right? So AI will confidently tell you, here's what you should be doing. They will take a moment and reflect on the output and basically say, like, yes, this is what I'm going to do, or maybe this is not right, I need to prompt further. Whereas more junior engineers don't have that sense of systems yet, so it is quite difficult for them to draw that line. When it comes to actual plant floor data, there's quite a few groups who are trying to, I would say they're less end users. They're more, again, SaaS-based companies in our space who are trying to, again, draw insights based on that information. My current opinion is that, number one, it is very difficult to get tangible insights using AI from the raw plant floor data. So there's going to be a lot of, again, we talked about this, a lot of legwork that needs to be done before the data is in a form that makes sense. But also, number two, almost every manufacturer is extremely cautious, because again, we're not dealing with a web application in this case. We're dealing with physical machines. So when you give insights to make changes on the plant floor, you need to make sure that validation, or at least like specific guardrails, are in place. So there are pilots, there are companies who are trying to, I would say, R&D some of the tools. Engineers will themselves, like I said, query and put that data, like, hey, I have this line OE for these machines. What do you recommend? But I've not seen, at least I've not witnessed yet, kind of true ROI proven initiatives that have been like documented, or I guess like more explicitly explained. And to be honest with you, I would assume that the top organizations in the world probably are doing a lot more R&D, and are simply not, disclosing what has been done or what hasn't worked. So I am very curious on that side. There haven't been that many white papers published yet.
No, exactly. And I think the general message is there's a lot more to come, and things are changing constantly. We'll talk in 6 months' time, and it'd be a completely different picture then, of course,
Yep.
which we have to acknowledge. But no, as we I guess we come towards the end, it's been really really great to sort of pick your mind on this. Like I said, I think there's about 3-4 other episodes we could talk about and go into more detail, which I'd love to do in the future. But I guess just to round off our sort of discussions today, Vlad, and it's
Mhm.
the usual end of the podcast for regular listeners. It's what does the future look like? What can we say about the future industrial data? Where's the next horizon? AI, machine learning, LLMs, exactly. We all know that. There's maybe aside from that, but I don't want to put words into your mouth, so maybe I should just leave you to answer.
Yeah, that is the $1 million question. So again, I've had a few conversations with groups that are pioneering lights out manufacturing, right? And I've always been a believer in that concept. And lights out manufacturing, I guess if any of the listeners or viewers are not aware, basically it is the concept of having absolutely no human intervention within a manufacturing facility. I believe it is still very challenging. I think it is very difficult, but I truly hope that we, again, as not necessarily humanity, right, but maybe as like industry leaders, are striving to make plants better, in terms of operating as efficiently as possible from an automation standpoint. And we can obviously discuss the different markets, but I believe that in order to compete in a general sense, with the generally higher cost of labor, we need to automate more. So I think that with the rise, or I guess the decrease in cost of automation, again, for a variety of factors, we're going to continue to see plants pushing higher and higher the barrier towards lights out manufacturing. I don't believe that we will ever achieve it. I think it's still to an extent like an asymptote, right, where the cost gets prohibitively or exponentially higher at the closer we get to complete lights out manufacturing. But I do believe that groups will continue to get closer and closer to that barrier.
No, fantastic, and it sort of rounds off our chat today nicely, and actually points to again a lot of future episodes and future discussion points we could go into. But no, for today, Vlad, it's been a real pleasure to speak to you. This has been recorded, I can confirm, so that we will be hearing this episode. The world out there will be listening to this episode. So I'm really pleased you came back to re-record. We have done a better
Absolutely.
job. I've got a feeling that we've done a better job than last time. But no, it's been a real pleasure, and look forward to having you on again, hopefully.
Absolutely. Thank you so much for having me. I really appreciate it.
Oh, but of course, sorry, one thing I forgot. Oh, yeah,
Tell me.
because obviously I'd like people really fascinated what you've discussed today. Where can they find out more about you and what you're doing?
I would say the easiest place to reach me is LinkedIn. I do have my profile open, so if you want to send me a message, have a conversation around manufacturing, industrial automation, happy to answer any and all questions. I do have my own website, which is joltec.com, where you can find a bit more about myself, some of the projects, some of the initiatives, the things that I'm working on. So happy to connect with everyone. And like I said, have a conversation around manufacturing and industrial automation.
Fantastic. So yeah, we'll make sure those links are in the show notes as well for people. So, but yes, thank you again, Vlad, and thank you everyone out there wherever you are around the world for listening to this episode. And we'll see you on the next one. Thank you very much.
Awesome. Thank you so much, everyone.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.